Okay, I'm doing my presentation over spanning tree protocol concepts. This is an interesting topic to me. I really like this topic, so I'm going to do mine over this. Now there's two different protocols that kind of go back to back together. STP, then there's RSTP. What is STP and RSTP? Spanning tree protocols allows Ethernet LANs to have the added benefit of installing redundant links in a LAN. This means like if you want to use two cables to connect two switches together, just in case you have a failure on one link, then you got another link to be able to use so you don't lose entire connection from your switch. Using redundant links in a LAN design allows the LAN to keep working even when some links fail or even some entire switches fail. When you use redundant links, it can cause Ethernet frames to have a loop for an indefinite period of time. With STP or STP enabled, some switches block ports so that the ports don't forward frames. So what this is basically saying, when you do use redundant links, some of the biggest issues you can have is indefinite loop backs. So when you send a frame, it could just get caught up going around and around in a circle, not being able to make it to its destination. When you enable STP or RSTP, this allows you to basically close one link or one port and use just one port instead of both ports, and it knows what port to use. And this it definitely helps whenever it helps for you to have redundancy for your links, and it also prevents loopbacks. So this is really beneficial in a network. It's very important to understand STP and RSTP in the switches. My next slide, I have an example to show basically what I'm talking about. This right here explains how you got three switches and how you got designated ports are the green, root ports is the blue, and you have block ports as the red. So basically your main switch is going to be your designated ports, and you see where there's green on them. Then coming out of it, you have the first, your second and third switch is going to be your root ports that go back to your root switch. So this is your root switch, and it allows you to use one port. And basically what I was saying, how STP helps block one port, see how it got redundant cables, and it blocks one port, so it's going to be using this port, this Ethernet cable. This is going to be your root port with your designated port going to your root switch. And also you got a block port over here. So this prevents loopbacks, and it allows it to have one direction going to the root switch, the root bridge. This is very helpful when you have multiple switches in a network. Now, while we understand a little bit the concepts of STP and RSTP, I'd like to tell a little bit of the history of when STP was created. IEEE first standardized as part of the IEEE 802.1d standards back in the 1990s, with pre-standard versions working before that. Basically, the concept was already being thought of whenever for hubs, and it developed. It was more standardized by IEEE 802.1d in the 90s. Then the industry and IEEE improved STP with the eventual replacement of STP with an improved protocol called Rapid Spanning Tree Protocol. So basically, STP was the first version of it. RSTP is the newer version of it. It's basically the same concept, but it has added features in it, and it has a little bit of different names used too for ports. The IEEE first released RSTP as an amendment 802.1w, and in 2004 integrated RSTP into the 802.1d standard. And STP and RSTP works pretty compatible with each other. If you're using STP in your network, you can still use RSTP with some switches and STP with other switches, and vice versa. They could both work together with each other without no issues. So the concepts are still work together even though they're different protocols. RSTP works just like STP in several ways. So what since we know about STP and RSTP a little bit, I want to show what's similar with both of the protocols, and I'm gonna have another slide that shows the difference between the two protocols. So things that are similar in the protocols: RSTP and STP elect the root switch using the same rules and tiebreakers. What that means basically, it uses the same concepts to be able to select what ports it's going to use to go directly to the root switch, the root bridge, and what's going to be root port. It's going to have the same rules of what it's going to elect to be root ports and designated ports, and also it has the same rules of like whenever it's going to have the tiebreakers of what port's going to be over. If you have two cables you're using to two different switches, it's going to have the same rules of which one's going to, how it's going to decide the tiebreaker, which one's going to be the designated port, and which one's going to be the root port. RSTP and STP switches select their root ports with the same rules. RSTP and STP elect designated ports on each LAN segment with the same rules and tiebreakers. So designated ports, root ports, used the same way. RSTP and STP place each port in either forwarding or blocking state, although RSTP calls the blocking the discarding state. So this is kind of what I referred to earlier. It's like they have the same concepts, but sometimes maybe they'll use a little bit different names. So whenever STP will block one port and it selects a forwarding port, sometimes instead of calling it a blocking port, they'll call it a discarding state instead. Okay, RSTP adds to STP in ways that avoid waiting on STP timers. So this is a little bit of the difference between RSTP and STP. RSTP adds a mechanism by which a switch can replace its root port without any waiting to reach a forwarding state. So this speeds up the process a little bit. This makes it a little quicker to use as a protocol. It doesn't have to have much of a waiting time. And that's for the root port. RSTP adds a new mechanism to replace a designated port without waiting any forwarding. So basically these are all the same concepts, like it's just speeding up the process in different kind of concepts, but it's the same thing. So this one's for the root port, this is the designated port. So it's going to add a new mechanism to replace a designated port without waiting any forwarding. So this speeds up the process of selecting designated port. RSTP lowers waiting times for cases in which RSTP must wait for a timer. So this speeds up the process too, lowers waiting times for cases in which RSTP must be waiting for the timer. This is pretty handy. It's pretty good. A little speed. So if you have the options of using STP or RSTP, you definitely want to go with RSTP if you can. But like if STP is already used on the network, it's just fine too. You can still use RSTP when possible. RSTP and alternative root port role. With STP, each non-root switch places one port at STP root port role. RSTP then takes another step beyond STP, naming other possible RPs, identifying them as alternative ports. Alternative ports basically works like the second best option for a root port. So basically whenever they have two different ports that it can use for a root port, and it's going to have one root port selected, then the next port is going to be called the alternative port. So this helps, like if the root port ends up failing, then it can be switched over quickly to the alternative port, and this speeds up the process whenever you have a failing link, and it's able to have no issues of a switch going down. That's really beneficial. And I have another picture to kind of explain this issue a little better, a diagram. So this is a diagram that I'm using right here. So you got your root switch, and you got your root port, and then you got your designated port and backup port, and this is what we was referring to right here, your alternative port. You have an alternative port right here. So if this root port switch fails, then it could switch over to this alternative port to end up being able to still reach the root switch, the root bridge. And that's one thing that I like about Rstp over Stp. And this is pretty much my presentation right here. I just wanted to go over a brief understanding of Rstp and Stp and the importance of both and how they help in networks on switches. Thank you.